Hello and welcome to video 23 in my Rigging in Maya series. In videos 21 and 22, we created a script which will automatically rig our quadruped limbs. Now so far, this is quite basic as it simply adds the IK and FK functionality into both the front and hind legs. What I want to do with this video is take the script further and make the limbs stretchy. Again, because we are picking up from where we left off in the previous video, it's highly recommended that you watch the first two before this one. Before we get started, I just wanted to mention that you can now download all the source files for this and all my other courses from my CubeBrush, Coffee, Gumroad and ArtStation pages. You can find links on the screen and in the description below. I also wanted to tell you about the antCGi Club. Joining the club is a way for you to help support the future of this channel, as it will allow me to dedicate more time to creating new content just for you. But that's not all. You can also earn yourself exclusive rewards. These include all the course assets, models, rigs and custom made scripts, as well as access to the members only area of the antCGi Club Discord server. In addition to that, you can also claim a 10% discount on antCGi merchandise. There are two ways you can join. The first is to simply click on the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. Okay, so we are starting with the same scene we have used in the past two videos. Well, that's not entirely true. I had to make a few minor adjustments to the control hierarchy so I could better demonstrate the systems. So, if you have downloaded the source files and are following along, please use the files that go with video 23. Here we have the script we've written so far. We can select the root joint and run it. And there we have a rigged hind leg. We can also do the opposite side if needed. So, all good so far. We can even update this line of code here and the script will rig the front legs for us too. So we can essentially rig all four limbs just with the click of a button and a slight change to the code. But that could be achieved with a button on a custom made UI. Actually, that's a good point. Would you like me to expand upon this script further and show you how to build a basic user interface? If so, let me know in the comments below or on Twitter or over at the antCGi Club Discord server. Anyway, so yes, the script can save us a lot of time so far. So now we have this script, we can start to add extra features into it. So let's now look at making these limbs stretchy. Although I'll be scripting this process, you can head over and see how this is done manually with my stretchy limbs video. Okay, let's start a new section. I'll just copy this. Oops, this should be make stretchy, not male stretchy. That sounds a bit dodgy. The first thing we need to do is work out just how long this leg is. Once we know that, we can then detect when it should stretch. What we need first is something which will tell us where the end of the leg should be. Let's use a locator. And to create one, we can use the space locator command. That shouldn't have an E on the end. First we should give it a name, and let's use the same variable as we have been so far. So just copy this and change the end to stretch end pos. And also add underscore lock, just so we know it's a locator. I like to add these into names so it's easier to see what things are, and also search for them if needed. So adding lock means I can easily find all the locators in the scene. Now we need to move it to the ankle position. Again, we have done this before, so we can just grab this bit of code here and paste it here. And also update the name of the object we are moving. We can then use the joint hierarchy list to specify which joint we want to move the locator to. Paste this here. We can't use the I because it's no longer in a loop, so we need the number of the joint in the list. 0, 1, 2, 3. So the ankle will be 3. With the locator created and moved into position, we next need to move it to the paw control. So let's parent it next. Again, I can copy a line of code from here because we want the parent command. I'll update the comment too. We need the locator name here. And next we specify what it's parented to, so we can grab the paw control name which we built earlier. So now when created, the locator will follow the paw control. Now we have that created, we need to think about working out the actual length of the leg. We do this so we can tell when the leg straightens and should be stretching. What we need is a series of distance nodes which will tell us the length of each section of leg. We can then add those together to give us the full leg length using a plus minus average node. Let's create that first. So we need a shading node, and as mentioned, this needs to be a plus minus average node. Again, if you aren't sure of the spelling, create one manually in the node editor and check the output above to see what Maya does. Next we need the flags. So specify that it's a utility using AU equals 1. And then we give it a name. Just copy this again. We keep using the limb name variable, so everything associated with this leg has a unique name, and we can also tell which limb these nodes are used on. Let's just call this limb name length, because it's giving us the full length of the leg. Now we need the distance nodes. Because we need to work through each joint in turn, we can bring back the for I in range loop we've used before. Now we need to create a distance node for each section. We can use shading node again here. And this time we are creating a distance between node. Let's change the name to dist node. Now that's built, we can connect it to the joints. We will use the connect atta command to do this. We need to specify the joint's name first, so let's use joint hierarchy again. And we can use the loop to go through each item in the joint hierarchy list one at a time. So let's add I here, which will change each time the loop runs and give us a different joint from the list. This time we need to reference the stretch joints we created back in video 21. Yep, we are finally using them. We use those because they remain static, so will give us a true value of the joint's length. If we use the IK or the main joints, the length would change once the leg started to stretch, and you would end up with an infinite loop. So the leg would stretch, but then the distance between nodes would be reading the stretched value, so you wouldn't be able to tell when the leg was stretching because you don't have a baseline to work with. Thinking about it now, I do wonder if once you have the leg length stored, you can just delete these nodes and the stretch joints. I might need to look into that. Now we need to specify what attribute we want to connect, and from previous experience, I know this is the world matrix attribute. If you want to see this done manually, you could always check out my earlier video on stretchy limbs, just as I mentioned earlier. This will also show you the attributes you need. We now need to connect this to the distance between node. Actually, we need to change the limb name variable here or we'll end up with the names clashing and the script will break. It makes sense to just use the current joint name. That's better. And we need to connect to the inMatrix1 attribute. So this is taking the world matrix values here and connecting them to the first part of the distance between node, so we are specifying the start position. Let's copy this now and tell it the end position. First, let's change the distance between nodes attribute to in matrix 2, as this will be the second input. What we need is for the end position to be the next joint in the chain, or in our case, the next in the list. So what we do is simply add a +1 after the I. This will take the value I is and add 1 to it, so it will reference the next item in the list for us. We need to make 2 more connections now before we move on. Copy these 2 lines and paste them below. This time we want to connect the joint rotate, pivot, translate attributes to the point attributes. So change this to point 1 and this to point 2. This will now give us the length of each section of leg. Because this leg is in segments, we need to add the distances together, so we can now connect the distance between nodes output to the plus-minus average node we created earlier. We need to specify the distance between node first. Remove that +1. And we need the distance attribute this time. Now we need the plus-minus average node's name. We want to connect to the input 1D attribute. This attribute will take multiple inputs, because all it will do then is add these together for us. What we need to do is make sure that each time the loop runs, a different input is used, or we will end up with just one value from one section of the leg. We need the brackets for this. Again, if you do this manually, you will see that the attributes output with brackets and then the number, where the connection should be made. So just like with a joint hierarchy list, we would use 0 as the first input, then 1 as the second, and so on and so on. Because we are already in a loop, we can just use I again, as this represents a different number each time. So this will simply add the number into the name of the attribute. The problem we have is that in its current state, I represents an integer, which is a whole number. But when building names, we need a string, which is a piece of text. So if we ran this now, we would get an error because the name wouldn't be recognized. All we need to do is convert I into a string using str or str, and then putting I into brackets after it. Let's run this now and see what we get. Got an error. So this might be because as the loop is running, it's including the toe joints too. So let's tell it to ignore those. What we can do is use if I is not limb joints -1. What this will do is check the loop each time it goes through the limb joints list, and if it's working on the last joint, skip it. This stops a distance between node being created and used between the ankle and one of the toe joints, whereas all we need are the main leg sections. We also need an indent because this is now inside an if statement. I'll add a comment too, and run this. Another error. Right, I see now. I used brackets instead of parentheses. That's easily done, but goes to show how you have to use the correct syntax. Okay, let's try again. Another error. Right, I didn't undo before, so it's now finding that the joints already exist in the scene. Okay, I'll undo this time and run it again. That's better. If I open the node editor now, and move the outliner over, let's find the stretch joints. And bring those in. We can see we have the nodes we created here. I'll just open these. And we can see we have all those inputs, 0 to 3, which used that bit of code so each distance node was connected to a separate attribute. Let's bring in the rest of the stretch joints and take a look. Actually, I'll graph the plus minus average node as this has all the main connections. So here we have the stretch joints and the 3 distance between nodes. Basically, these 2 stretch joints are connected to the distance node here, and the distance from that is going into the plus minus average node. We can see the 3 distance values here. The operation is set to sum by default, so that will add all those for us. And under input 1D, we have the values it will add. Okay, let's close that. And we will remember to undo this time. So we now know how long the leg is. So next we need to find out when the leg is going to start stretching. To do this, we need to check when the distance from the first joint in the chain to the stretch end locator is greater than the overall leg length. So we need another distance between node. We can copy this line here. And remember the indent. Just the one though, we don't want this to fall under the above loop. Let's give this one a new name. And as it's not in the loop, we can just use the lim name variable. Because we are using another distance between node, we know we will need the same connections as above. So let's just copy that code and update it. Okay, so first we need to change the start position joint name. But all we need to do is change I to 0. So it's the first joint in the list. Actually, let's add stretch to the name here too, so it's more obvious what it's for. Good, now copy that and replace the dist node names below. Now we need the name of the stretch end locator. So copy this. This will be the end position, so we can replace the joint hierarchy names here, the ones where we added +1. Because this section and the one after it are both strings, we can also remove the plus here. And that extra stretch too. That's better. Let's update the next section. So change this to 0. And add the locator name down here. Just paste this. And then add rotate, pivot, translate back in as the attribute we need. This will now give us the distance from the femur to the stretch locator, which is parented to the paw control. Now we have both distances calculated, we can create a network which will check for the stretch and activate if needed. Actually, let's run this first to make sure those distance nodes are created correctly. Looks like we have an error. This is why it's always good to keep checking your script. Here we go. I left the joint hierarchy name here when we actually need lim name. I'll just replace these. Okay, let's try that again. Good, that worked. Undo and continue. We are now going to create a multiply divide node which will act as the scale factor. All this will do is check the 2 distance values and tell us when the distance from the femur to the locator is greater than the leg length. First, let's create a new multiply divide node. And we can call this scale factor. We now need another node, this time a condition node. This will be used to control how the stretching works. We can speed things up by using the same line of code as above. This time we need a condition node though, and rename this to condition 2. Okay, let's run this so we can see those nodes. I'll bring the outliner over too. So there's the new condition node. Here it is in the attribute editor. First we need the operation to be set to greater than, because we are checking when one distance is greater than another. If we bring back the script editor, we can see the code we need to use here. Let's set a few more attributes while we are here. So, we need the second term to be 1. This is because the first term will be our updated distance value, taken from the scale factor multiply divide node. We will check if it's greater than 1, and if it is, the leg is stretching. Next we can set colour if true to 1 as well, although we will be changing this later. This will just give us a good base value to start with. So if we go back to the script editor, we can see the mel which updated those attributes for us. Okay, let's find the multiply divide node. There it is, scale factor. What we need to do with this node is change the operation from multiply to divide. And there's the code for that too. Alright, let's undo everything. And close that. Let's add those settings into our script. We used the setAtter attribute earlier in the script, so let's just copy that. There's one. And paste it here. Okay, let's do scale factor first. So let's update the name. And find the attribute we need. There it is, operation. Update the attribute down here, and we can see the value we need to set it to is 2. So we can remove this and replace it with 2. Nice and easy. Okay, let's update the condition node next. If we look in the output, we can see we need to change the operation attribute too. Plus it needs to be set to 2 as well. So this line is already done. Let's add 2 more. Second term next. And we set this to 1. Now colour if true are. And this also needs to be 1. So that was quite easy and was mostly just copying and pasting. We have all these nodes now, so let's start to connect them. First, the scale factor node. I keep calling it scale factor when it's just a multiply divide node. Make some space and grab this line here to start us off. First we need to add the stretch distance node, the one which gives us the distance from the femur to the locator. Just copy the name here and paste it here, and then change the inMatrix1 attribute to distance. This is the output from this node and will give us the full distance from the femur to the locator. We want to connect this to the scale factor node, so we need its name next. Paste this here and change the attribute to input1x. So that's the first input done. Now let's add the second. Add R onto that. What we need now is the full leg length. All we need is another connection, so let's copy this. And this time we want the distance value to come from the leg length plus minus average node, the one which adds together all the distance nodes. So this needs to be output 1D, and this wants to be connected to input 2x this time. So we can keep the scale factor here because it's the same node. Now that's set up, we can move on and connect the scale factor node to the condition node. Again, just using another connectAtter command. We now need the output to come from the scale factor node, so we can copy this over here. And the attribute just wants to be output x. Again, if you're not sure what attributes to use, build it manually and make a note of the attributes you use. This attribute needs to be connected to the condition node, so we need the name changing here. And the attribute we need is first term, because we want to compare the first term value, which is a scale factor, with the second term value, which is currently 1. As well as connecting the scale factor to the first term attribute, we can also connect it to the colour if true attribute. Because the scale factor will increase as the leg scales, we can also use that value to drive the joint's length, which will make them stretch. So we need another connection. And we can just copy the attribute name from here and paste it here. So now the output will be the scale factor value. Because we have a new connection to the colour if true attribute now, we can remove this line here as it's no longer used. Okay, it's been a while since we tested this, so let's run it again and make sure everything works and there are no spelling mistakes. Okay, no errors. Always a bonus. Let's check the outliner. So there's the main condition node we are using to drive the stretchiness. Not sure what these errors are. It's not an issue with the script. I think it's just Maya being stroppy, so I'll just ignore them. Right, let's open the node editor and graph the condition node and check everything is where it should be. Open these up and make this bigger. We have our stretch joints. And the distance node here, which is the one that checks the distance from the femur to the stretch end position locator. Here we have the plus minus average node, which adds up all the sections of the leg and gives us the full leg length. So this goes into the input 2x attribute on the scale factor node here, and the stretch length goes into input 1x. So these two values will be divided by each other, and will give you a value of 1 when they are equal, meaning the leg isn't stretching. Because joint scale values in Maya are set to 1 by default, we can use this value directly to drive the scale values. If the locator distance is greater than the leg length, the value of 1 will also increase, meaning the leg is stretching. What it also means is we can again use a scale factor output value to drive the joint scale, making the leg stretch. What we do then is use the condition node so we can control how and when the leg stretches. All we need to do now is make the output from the condition node drive the joint scale values. It's a lot to get your head around, I know, but once you start building these networks, it kinda makes sense. Okay, let's move this and undo everything. Alright, so we want to connect the condition node now to the IK leg joints, so we need to do this to each one in turn. So let's use our trusty for iron range loop again. We want another connection, so I'll copy this line. We want to connect from the condition node, so I'll update the names here. And we want the attribute to be output color R, because we've been connecting to the R channels of the node, so we need the R output. This is going to connect directly to the joints, so we need the joint hierarchy list again. We can keep the I in the brackets because we are using the loop, so this will change each time the loop runs and work through each joint in the list. It will do this until it hits the number which is stored in limb joints. At that point, the loop will end. We can change this to IK because we want to connect to the IK joints. And we are connecting to scale X because this is the axis which points down the joint. So if we scale it, we can see the joint stretching. Alright, let's test this now. If I move the paw control now, we should see the leg stretching. Well, the femur looks like it's working, but nothing else is. What we also have to remember is that this is the rear leg, so we also need to stretch the driver skeleton too. The leg isn't working here because the IK handles aren't moving with the leg, so the lower sections aren't stretching. Let's bring back the rig systems so we can see them. So we want the ankle to be locked to the locator. We can see that the leg is stretching slightly, but not enough. Okay, let's add in the driver leg, which should fix the issue. Okay, undo again. We need to use our check again to make sure this is a rear leg. And if it is, all we want to do is connect the IK skeleton's ScaleX attribute to the driver skeleton's ScaleX attribute too. So then everything scales. Let's try this again. And move the paw control. Great, the whole leg scales now, which means it's stretching. Right, time to check the front leg. So let's update this and set it to 0. And run it. And move the paw. Perfect. That's what I like to see. So we could leave this script here. The legs are rigged now and they stretch, but let's add in a bit more functionality for the animator so they have more control. If we select the paw control and close this, you will see that there are two attributes here, stretchiness and stretch type. If we look at stretch type, there are three options. We can use this to control how the leg stretches. Again, this just gives the animator more control. With stretchiness, we will add the ability to turn the stretchy limb on and off. Well, you will be able to blend between the two states. Okay, let's add a new comment. And we need to create a new node. So let's copy this line here to start us off. This time we need a blend colors node. And let's just call it blend colors to keep things simple. I guess you could call it stretch control or something similar if you wanted to. I'll just make that a capital letter for no other reason than it looks better. I recently discovered that this way of writing code, so using capital letters in names where there would be a space, is called camel case. One of my subscribers pointed this out to me in a recent live chat, and I just want to shout out and say thank you to them. Unfortunately, I cannot remember the name of the person who did it, so apologies for that. What this node will do is sit between the scale factor node and the condition node, so we can control what values are used. We will essentially use the blend colors node to blend between the scale factor value and a static value of 1. When it's set to 1, the leg's scale will be 1, so won't stretch. We need to create a new connection now. We can just copy these. So we want the scale factor output attribute, and this is going into the blend colors node. And we want the color 1R attribute. We now need to make a connection coming out of the blend colors node. So we want the output this time, so output R. And this will go into the condition node instead. So by doing this, we are overwriting some of the connections we made earlier, but we can go back and clean up the script later. We have the full name and attribute here, so let's just copy that. Let's run this so we can see what we have. Oh, hang on, just undo that. We had it set to front leg, that's why it wasn't working. Okay, update this again. And run it. So we have a problem now. When the leg reaches the point where it's supposed to stretch, it snaps back. Let's find the blend colors node and close this for now. Here we have the blender attribute and it's currently set to 0.5. If I adjust that, you see the leg shrinks and then goes back to a normal length. This is because the scale is blending between two R values, so color 1R and color 2R. Color 2R is set to 0, that's why the leg is shrinking. All we need to do is set color 2R to 1, so the scale value will either be the stretch or a value of 1. That's better, the leg no longer shrinks. If I move the control away and use the blender attribute, the leg now stretches to meet the locator. So we can use this to turn the stretchiness on and off and blend between them. What we can also do to make things easier is connect the stretchiness attribute on the paw to the blender attribute, so the animator isn't directly accessing the nodes. Okay, let's add this to the script before we forget what we were doing. Let's connect the blender attribute first. We can see in the output we have the name of the attribute. Let's grab the paw control name variable. We will add this first because this is a main driver, and use the stretchiness attribute. We don't need the blend colors here because that's not part of the paw control name. We do need the blend colors name here though, because that's what we are connecting to. If we look back up at the output, we can see the attribute we adjusted here. So we can copy that directly. That's the main control connected. Now we need to update the other attributes, and we can see those here. Again, I'm going to cheat and copy a line of code I used before. This set atta one here. Let's add it here, just after the blend colors node is created. We need to update that to blend colors 2, as that's the node we are editing. And the attribute we need is... Actually, let's take a quick look in the node editor. Because we are using color 1R as the input for the scale factor, we need to use color 2R as the opposite input. What we can do though is simply use one line of code to edit all three at the same time, just specifying color 2 as the attribute. So we want R to be set to 1, G to be 0, and B to be 0 too. So that's a quicker way to set the attributes using the same line of code. What we also have to do though is specify a type, so we use 3. Okay, let's roll back and try this now. No errors, that's a good sign. So the leg moves well. It isn't stretching though, but the stretchiness value is set to 0. Let's adjust that. Great, the leg stretches. Okay, there we have a stretchy limb and it's controllable. Alright, let's undo again. And now let's look at setting up the stretch type attributes. Actually, let's run the script and rig the leg. So the idea is we want these options here to drive the condition node. I'll just find it. What they will do is change the operation for us. So when we want the leg to stretch, as it does now, the stretch will only be triggered when the operation is set to greater than. Because when the locator distance is greater than the leg length, we should stretch. We can change the operation so the stretch is triggered at different times. So this will change how the leg works. What we are going to do to achieve this is use set-driven keys. I don't normally use set-driven keys unless I have to, but in this case they work really well. Just like with any scripting, you should set up the set-driven keys manually first and see what Maya outputs, so you get the correct code. Okay, let's set this up. So with set-driven keys, what you need to do is set up the attributes and then store a key. So there's a lot of repetition. All this means from a scripting point of view is that you can use the same line of code and just update the attributes, so it makes things easier in a way. First we set the attribute on the paw control. Let's change the attribute so we can see what Maya gives us. So we need the stretch type attribute, so let's add that here. And we just need it set to 0, which means it's set to full. We don't need this section here. We've set the paw attribute now, so now we need to set up the condition node. We need the condition node name here. And I already know the operation needs to be set to 1, and I can add a comment after to remind me that this will be set to not equal. This will mean the leg stretches and also squashes. Once those attributes are set, we need to store a key, so we need a new command. Set driven keyframe. Oh, I forgot to add the actual attribute here. So this should be operation. We now need that full name, including the attribute, because we are setting a driven key on it. For the second attribute, we actually need a flag, CD, and this will be the driver, so the stretch type attribute. If I show you the flags, you can see CD here, which is current driver. Okay, so that's the first set-driven key stored. Let's copy this and do the next one. So we just repeat the process again, but set different attributes. This time we will set stretch type to 1, which is stretch only. And the conditions operation attribute will be 3. This will change it to be greater than. So the leg will stretch but not squash, so we'll maintain the natural bend. We can keep this line the same because all we are doing is storing another keyframe. Okay, now let's set up the third option. Copy this again. This time set stretch type to 2, which will be squash only. And the condition operation will be 5 this time, which sets it to less or equal. So this time the leg will squash, but it won't stretch. Finally, we will set the stretch type attribute back to the default value of 1. And as this is the end of this section of script, we will clear the selection. Right, let's give this a final test. Actually, I need to undo everything first. Okay, back at the start. Okay, here goes. Yay, we have an error. We were so close. Let's have a look. Ah, okay. I forgot the period between the name and the attribute. Simple mistake. What's good is it tells us a line where the error is too, so we can find it easily. Let's add these in. Ah, okay, I must have missed some. It was these, sneaky. Okay, now let's test it. Fingers crossed. Yeah, that seemed to work. Let's adjust the stretchiness. looks good. So stretch type is set to stretch only. Let's switch to squash only. The leg is no longer stretching, but it squashes. Now let's try full. Great, now that squashes and stretches. So those all seem to be working just as I wanted. Let's set it back to stretch only. And the leg works nicely. We still get the bend when the leg is at its normal length. Let's try the right leg. Okay, turn stretchiness on again. You can probably set this to be on by default actually in the script. Okay, looks good. Let's try the front legs now. Remember to change this setting. Moves okay. Let's enable stretchiness. Okay, great. Now the right leg. Nice, that's all the legs set up with stretchy limbs and it's all automated. Okay, I'm going to end on a high point here and leave you to play around with the script. What I want to do in the next video is expand upon this script even further and add in the roll joints. And then what I would like to do after that is come back to the stretchy limb and explore adding in volume preservation. Well, we've come to the end of another video. Thanks for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications so you are kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below or contact me through the antCGi Club Twitter account and I will try my best to reply. Alternatively, you could post them in the antCGi Club Discord server where I spend more of my time. You can find an exclusive invitation to join in the description below. Remember that you can also join the antCGi Club to help support future videos while also earning exclusive rewards. Alternatively, if you would just like to show your appreciation, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is antCGi signing off and I will see you on the next one.